In this video we'll use simple example of database schema with two tables to go through basic core concepts of SQL and relational model, including basic SQL syntax, joins, conversion and aggregate functions. We'll use example from Oracle sample HR schema with departments and employees. Employees work in departments and departments have managers. We'll discuss SQL concepts by answering following questions. Display names of employees with salary greater than 1400. Which employees were hired in this and past year? List departments and their employees, including employees not in department and departments without employees. Display aggregate salaries of departments with over 25 employees. To demonstrate certain points, I'll be using Oracle and Postgres databases. Let's start with the question, name of employees with salaries greater than 1400. Basic building blocks of SQL query are from, which names the tables we want to fetch data from, and select, with which we choose columns. We can choose all columns from table by selecting star from table. In this case, employees. We can restrict which rows to select by using the where clause. And in our case, we'll restrict salary to salary greater than 1400. Where clause tells the database which rows to filter, and if needed, we can chain additional and or restrictions. Let's say we only want employees with managers, so we'll say that the manager ID should not be null. One thing to note is that AND takes precedence over OR, so if we say that job ID should be like IT, this query will effectively group job restriction into one group and salary and manager restriction into another. And if you execute it, we'll see we'll get two rows from our previous query and all IT programmers as well. So this query is effectively equivalent if we'd use parentheses to this query. So word of caution, you can always use parentheses to avoid implicit mistakes with AND and OR precedence. Select part of the query enables us to restrict columns we want to select. It's called projection, so we'll only select first and last name. Order of results that we are given is not guaranteed and is at random. We can guarantee the order by using the order by clause, and we'll order by last name of the employee. This showcases basic building blocks of SQL query. Select to choose the columns, from to choose the tables, where to restrict the rows, and order by to order the result set. And to answer our original question, to name employees with salaries greater than 1400, we'll just leave the required restriction and run our query again. Our second question is how many employees were hired in this and past year. To answer this question, we'll need to use basic building blocks of SQL query we've seen in previous example, and in where clause restrict on hire date. Let's first try to hard code our where condition. I'm recording this video in 2025, so this and previous year will be 2025 and 2024, so hire date should be greater than January 1st of 2024. How do we tell the database that? Let's select 2024 January 1st. As a quick side note, I'm using Oracle version 23 which supports plain selects. If you were using some previous versions, you would need to have a from clause as well, and you would use from dual. That's Oracle's built-in table which has one column and one row. To get back to our example, this was interpreted as numbers, so 2024 minus 1 gave us the result of 2022. We can quote our expression, which will give us a string. To tell the database we want string to be interpreted as date or as number, we'll need to use conversion functions, to date and to number. And the opposite is true. If we wanted to tell the database to interpret the number or the date as character, we'll use toChar function. So let's use toDate function. Would that work? And it does not work. We get an error. Literal does not match format string. It does not work because for conversion functions we actually need two things. We need the value which we provided here, but we also need a format string, which is a way to tell the database how to interpret the value. In our case, we'll tell the database to interpret first 4 digits as year, followed by month, and then followed by day. And that does work. There is default format for dates that database comes installed with, and we can check that in Oracle by checking $NLS parameters, and we see that default format is DD month and then 2-digit year. So if we provide the format Oracle expects in toDate function, which is 1st of January of 24, that does work. It works even without the format string, but only on this instance of the database. If you want your queries to be truly portable, you would need to provide format string as well. So we can get the answer to our original question by selecting all from employees, where hire date is greater than this hard-coded January 1st of 2024. But of course we don't want to hard-code the dates. We want the query to fetch employees hired on this and past year, and we want the query to work in 2026, 2027, etc. And in order to do that, we'll need to use database building functions that provide us a way to fetch the current date and to work with the dates and intervals. In Oracle, we can fetch the current date by using the sysdate function. In Postgres, we can do the similar thing by using the current date function and current timestamp as well. Both databases also have built-in functions to trunk date by month or year. And both databases also provide a way to work with intervals. So if we trunk the current date by year, we'll get the January 1st of the current year, and then we can subtract the interval of 1 year to get the January 1st of the previous year. In Postgres, we would use date trunk function. We would trunk by year, current date. This would give us January 1st of the current year, and then we can subtract the interval of 1 year from it, which will give us January 1st of the previous year. In Oracle, similar thing. We would trunk sysdate by 4-digit year. This would give us January 1st, and then we can subtract the interval of 1 year. And we can use this expression in our original problem to replace the hard-coded value. A broader point here is that each database provides built-in functionality to work with dates, and it's similar but also different between various vendors. Let's demonstrate this on an example. What do we get when we add 1 month to the last day of February, 28th of February 2025? In Oracle we get 28th of March of 2025. And how about if we subtract 1 month from 31st of March of 2025? In Oracle it doesn't even work. In Oracle result would be 31st of February of 2025, which is not a valid date. And let's try the same query in Postgres. In Postgres it does work, and subtracting 1 month from 31st of March would give the last day of the February, 28th of February. And adding 1 month to 28th of February would give 28th of March of 2025. So can you use something in Oracle instead? Well, yes, you can. Oracle has add months function, which when you add 1 month to 28th of February, it gives last day of March, 31st of March, and it can subtract 1 month from 31st of March and give the last day of February, 28th of February. So to conclude, database vendors provide rich built-in functionality which you need to learn how to use. Our third question is, list departments and their employees, including employees not in department and departments without employees. First thing to notice is that data and employees and departments tables are related. In this case, relationship goes both ways. Employee works in department, marked by department ID column from the employees table points to ID column of the departments table, but also department has a manager, marked by manager ID column from departments table pointing to the ID column of the employees table. Referential integrity is a constraint on database design that makes certain that each foreign key in a table points to a primary key value in another table. More practically in this case, it means we need to assign employee to existing department, and we also can't delete departments that have people working in them. So if I select all employees, I'll see that a couple of them are working in department 90. If I try to delete department 90, I'll get referential integrity constraint violation. Child record found. For our assignment, we need to connect data between employees and departments table, and we do that by using the join clause. There are different types of joins: inner and outer joins, left, right, and full joins. We'll need to use appropriate type of join. So we'll need to list also employees that are not assigned to department, so department ID is null. We have one such employee, but also departments that don't have any employees assigned to them. Let's just take a brief detour to explain what different types of join do before we continue. Inner join keyword selects records that have matching values in both tables. In case of employees and departments, we'd get all employees that are assigned to departments and departments that have at least one employee working in them. Outer joins are joins that return matched values and unmatched values from either or both tables. In case of left outer join, we'd get all rows from left table and matched rows from right table. Right outer join is symmetrical case of left outer join, with difference being we'd get all rows from right table. In full outer join, we'd get all rows from both tables, matched and unmatched. Inner and outer are optional keywords, and if we break it down, plain join is the only inner join, and left, right, and full are outer joins. To make our life simpler, we can omit inner and outer keywords, since they are optional. If we do that, we'll see that in fact we only have few options. Just join when we have matching data, or other three when we are missing data on either side. So in our example, we have data that's missing on both sides. We have employees that are not assigned to departments and departments that don't have employees assigned to them. So solution in this case would be to use full join and join employees on department ID is equal to department ID. Let's print out some additional employee columns to make it clear. So first name, last name, department ID. I'll also add a where condition to display only rows where employee department ID is null. And by looking at the result set, we see we get employee that's not assigned to the department, and we get departments that don't have employees assigned to them. Let's try to use left and right joins instead of full join. In our case, departments table is on the left of the join and employees table is on the right. So if we use left join, we'd get matched rows and unmatched rows from the left table, which is the departments table, so we'd only get rows for departments that don't have employees assigned to them. In our result set, we dropped out that one row for the employee that's not assigned to the department. On the contrary, if we use right join, we'd only get this one employee that's not assigned to the department. We'd get unmatched data for the table that's right of the join. In this case, this is employees. And left and right joins are symmetrical, so if we switch employees to the left side of the join, we can use left join and get the same result back. So let's do that. We'll switch employees to the left side of the join, switch departments to the right and use left join, and we get the same result back. But our original question demanded that we display unmatched rows from both sides, so instead of left, we need to use full join. Our next assignment is to display salaries of departments that have over 25 employees. We'll need to use aggregate functions and aggregate clauses, group by and having, to accomplish this. Let's first display salaries and number of employees in departments. We already have two tables joined. We don't need the where clause, and we'll leave department name and department ID columns. And we'll only select these two columns, and we'll use aggregate functions sum and count to display total salaries of employees in department and number of employees. So we'll sum employee salary, and we'll use count. It doesn't matter on which column we count. We can count all, or let's say employee IDs. If you try to execute the query as is, we'll get an error. We've used aggregate functions sum and count and plain column names in the same select, and we need to tell the database that we'd like to group by on those columns. So we'll select the columns we want to group by on and use group by clause. And next we need to restrict our result set to only departments that have over 25 employees. Our aggregate function count gives us the value we need to filter on, but we can't use this value in where clause. Group functions are not allowed in where clause. Instead, we need to use a special having clause, which allows us to use aggregate functions for restrictions. So having clause is like a where clause where we can use aggregate functions. Let's use it. And we get the answer to our original question. Shipping and sales are departments that have over 25 employees and their respective salaries. Additionally, I want to bring the point home that having is like where for aggregate clauses, in a sense that we can use plain where restriction in there. So let's say we can say that give me only department IDs with the ID 50. And that works. The normal where condition works in having clause. With this, we went through core SQL clauses, saw how to use conversion and aggregate functions and how to join tables. Let me know in the comments if you'd like to see more tutorials on SQL.